Hey everybody, and welcome to Sofox shows off the Arduino Starter Kit. Now we have number 14, Tweak the Arduino logo. Now this is a really interesting one because up to now we've had our nice little Arduino and it's controlled a bunch of stuff, and sometimes we've got the Arduino to send signals back to the computer saying, hey yeah computer, you know what, I think that there's some this is the value of this, this is the value of that, isn't that all sort of good? But this is going to be very different because we are actually going to be using the Arduino to control the PC, as in this little thing right here, which you're actually, like looking at. Well, actually, you're not actually looking at it. I'm looking at it. Okay, trust me, we'll see how it goes. The point is, let's just start. Now, in order to communicate between the Arduino and the computer, we're going to be using serial. Now, we've already used a bunch of serial connections. It's that thing where I say serial, and here, let me just take a look at show you the last project. So as you can see, we've already been using serial in a lot of places, but that's just been for printing values. What if we want to actually use it more than that? And indeed we can. Now, as the book says, first of all, they need to agree on the frequency, which is nearly always 9,600. But in order to get this working, we need to not just have the Arduino send signals, we need the computers on the other side to send signals. So, how do we do that? Well, I've gone to a website called processing.org. Let me just include it there. If you go there, you will get access to what's essentially a whole system for a completely new programming environment, which is where we will show this all. So first of all, let me just show you what a processing.org window looks like. It's also in Java, so it's got a language fairly similar. There we are. Yes. So there we are. And you might be thinking, this looks kind of like the Arduino environment. And that is because you are totally right. It is kind of like the Arduino environment. So, with this, we can basically we can actually get signals. Now you might say, okay, well what can this processing.org environment actually do? And that's a really good question because I haven't really looked into it that much. So let's just try to write some basic code to see if we can actually get something running using processing.org. So like Arduino, I mean this is why they chose processing, because it seems kind of similar. Okay, we set the color mode, and yeah, and then we have the draw mode. Sorry, instead of update, it's draw. And what do we put down? We put down. Okay. How about background 122. 255 close enough. So when we run this, just wait a second. Okay, you can't see that, but I need to, let me just give it access to that screen. There we are. That little tiny window there is what we just drew. And you might think, wait, that's a tiny little window. Does it even do anything? And yes, it does. If we change this to 255 and then just run it, there we are. So as you can see, it's really, really simple. With a couple of lines of code, I just had a red square appear on the screen and I'm able to change its color. As you can see, this is rather basic, but no, it's doable. It's what we can work with. The real question is that this program is running off of my own PC. Can I run it so that the actual Arduino controls it? And that, my friend, is what we're going to try to answer now. Although, technically, if that wasn't possible, I doubt they'd be writing a chapter on it. So let's start off with just laying out the Arduino as they want it to be laid out. We take out. As you can see here, it's incredibly straightforward to set this up. It's pretty much just one single potentiometer. So all I need to do is grab the potentiometer, which is somewhere around here. Well, first of all, I'll just get rid of some of the spare wires. We still have the plus and minus hooked up to their respective stuff. And okay, I've got the base for the potentiometer, and now the Twizzly thing. Yes, Twizzly thing is an official term for the potentiometer. And Yeah, there we are. There's the actual base. So we set up our potentiometer just like we normally do. One there, one there. Push it in to make sure it's actually connected and hope we don't accidentally break one of the connections like I did last time. Okay, so as always, the top goes to plus, the bottom goes to minus, and then there's a big wire. Yeah, there we go. Top goes to plus, bottom goes to minus. Wait, wrong one. And the big long one goes all the way to A0, where we can read its analog input. Next up, we just need to take that little knob thing and stick it in. So we've done this several times before. It pretty much doesn't change that much. Let me just go back to first of all, we'll save our current Arduino project has logo, and set this up using the right sort of code, which is right here. So serial begin 9600 as it normally is, and then we go to the standard stuff. Then we just need to measure the value. Serial dot write ANALOG or EAD A0 divided by 4. Now this is different as it normally is. Instead of saying serial dot print, actually let's do quickly print line just to make sure everything is working. As I say, it's always good to test at each step in the process. It's already hooked up, and let's look at the serial monitor, which also reads all the serial output. Okay, as you can see right now it's 155. We tweak it to one side, it's 0, tweak it to the other, it's 255. So, sorry, let me just, there you are. Tweak it to one side, other side, okay. So that shows that the serial monitor does work, and it is everything is hooked up there. But what if instead of doing print, we do write? And you might think, well, that sounds good, but what does that actually do? And the answer is that that's what we're going to find out. We are going to go back, we are going to get a program on this side of the computer to actually respond to the values. Just like it used to pop up in the serial monitor, we're going to do it. So let's start this out. First, import processing.serial.hash. This will mean that this will give us access to processing serial library. Serial.myPort and PIMAG logo. So that's that basically means that logo. So that sets up the port and the logo. We then go int UG color equals 0. Sorry, I made a mistake there. See, this is actual, this underlines things in reds if you make a mistake. Not like the Arduino, which lets you like figure it out for yourself. Setup, yeah, we set the color mode, and then we load the logo. Logo equals load image. Okay, I'm gonna have to do http arduino.org logo.png, and because I had this experiment before, I'm going to check on a web browser where this actually works, because I'm pretty sure it doesn't. Yeah, I thought you are now being directed to arduino.cc. Please wait. Great. Okay, I can tell you that the Arduino logo doesn't work, but this URL actually does work. Yeah, there you are. That is, so that's it. Okay. Come to think of it. Okay, so now that we've got our logo running, next thing we need to do is just keep finding it. Okay, size logo.width logo.height. I believe this sets the size of the actual screen. Print ln available serial ports, and then it's print ln serial.list. My port equals new serial. This serial, or il dot list next here. So basically, it just chooses whatever the first serial port it sees in the list of serial ports, and essentially, as you can see, there's the 9600 popping up again. So, which is obviously the frequency we're using. And we go back to the draw. So draw if my port.available, in other words, if it's available, then bg color equal my port.read. This means it's reading the actual input from our potentiometer, which, as you see, was divided by 4, so it's going to be between 0 and 255 because the original potentium. Yeah, and yeah, print ln bg color, and then we go back to background, change this to bg's color, change this back to 255, and to think it off, image logo 0 0. Okay, so let's start this off with just doing the standard thing and actually trying to run this as a regular sketch and just, oh, cannot be determined, only numbers not variables for size command, resize reference. Wait, what? I made a mistake? Where? It's got shaky, okay, here in a second. It says fix the size line to continue. Logo.width, logo.height. Don't tell me there was a specification change. No. Logo is definitely a load image. I'm getting an error here. It says size of the sketch cannot be determined for your code. Use numbers, not variables for this. Oh, okay. Basically, it says use only numbers, not variables for the size command. So, which is screwed up, but whatever. So I'm going to load it directly. I'm going to inspect the element of the image I'm downloading. It's 170 by 116. So I'm going back here and 170 by 116. Okay, let's try this. Okay. Okay, let me show you all what I'm seeing right now. Yeah, I do not know what it's doing there. It's having something that I'm worried will lead to an epileptic attack if I keep leaving it like that. Apologies to all people who are having to put up with that. Okay, oh, I know. Fortunately, it's giving us a nice little number output here. So let's take a look. Let's try just stopping it and just looking at the numbers. Okay, so it's going... Okay. Available serial ports COM4, which should be it. Okay, that looks like it's right. And then we have my port equals new serial, this serial.list 0, which is the 0th one, and 9600. So it should be getting the right value here. So why is it not? Well, let's take a look at BG color. BG color equals 0 here. Maybe, first of all, let's try muting this and just making sure. Yeah. Yeah, that's working. It's just a simple red. So something is causing it to get really, really weird. I'll go back to printing out the ports and let's take a look at the numbers here just to make sure if there's anything weird going on. Okay, 56, 13, 49, 56, 14, 39. This is weird. It feels like I'm making a mistake somewhere. I know, I'll try to re-upload my sketch, because maybe what happened was it actually is doing the, I wrote down the right, so let's try it again. There we are. Okay, what was happening was, it was, remember the way that I had it so that it was like printing out the output and then I switched it to right? After I tipped right, it wouldn't. So let's try it now. Okay, nothing's changing. Well, I consider this a partial square. So let's see, why is it not changing? Oh, it's just constantly red the whole time. Okay, that's not good. Play it again. Okay, wait, it's getting something. It's 5. It's still 5 and 6. It's just 5 and 6. No, this is not right. This is not how it should be working. Arduino clearly says that it should be reading from analog points A0, then dividing that by 4, which should give us a number from 0 to 255. When I was printing it out, we saw this. But now it's just going either 0 or 5 and 6. Okay. Now I'm just going over the pages again. Maybe it must be reading from the same port or something. I mean, like, I don't see it not. Serial begin 9600. That's the Arduino code. Serial.write. Oh! Okay, I've left out a small delay. I need a delay 1. Now, I don't know. DLY 1. Now, I have no clue how much this actually affects things, but it's probably not helping things. So let's try running this. Let's try running that. Okay, it's still 0. And twisting the stick doesn't seem to do anything. So probably it wasn't that. Setup serial begin 9600 serial.write analog read delay 1 and they keep going. Import processing serial my port. It goes to the logo. BG color equals. Oh wait, something happened there. You saw it, right? I could have sworn it was there a second ago. I swear I saw a change in color there. It's at 241. Maybe I need to get rid of the print statement. That's not. Okay, this is not working. Okay, it's 255 now. It's not changing. Okay, go back to the processing thing. Serial.list, new serial. This serial. My port equals new serial. Yeah. This serial is 0, 9600. And the draw should be my port available 0 is greater than 0. BG color equals my ports dot read print BG color. So what is it not picking up the serial? What is going on? What is your major malfunction? Okay, I have an idea. We'll just use the serial monitor on the actual Arduino itself. Okay, and this is what it's putting out, which is just question marks. Ah, but you see, there we go. When we gradually turn it, we go through the entire ASCII alphabet. This is pretty hilarious. Oh, sorry, you gotta move serial up here so you can actually see it. But yes, it's just printing out a lot of weird stuff, which is cool because that's what ASCII is. See, now I'm into quotes. These are commas. What's happening is it's giving a value from 0 to 255, but they're being translated into ASCII characters. As you can see, we're on P, Q, or S, T, U, V, W, X, and these are all the, and now we're on to lowercase alphabet. And these are just weird symbols that it just doesn't know how to. So let's go back. So this is actually working. I mean, it's the Arduino at least is totally picking up what's going on here. We got like exclamation marks, 1, 0, 1, 2, 3, 4. This is, and then we hit all the capital letter alphabet, lowercase alphabet. That's really cool. But it does show that these serial data is definitely being transmitted. I mean, we wouldn't be seeing this if it wasn't. It's just translating it one byte at a time. As you can see, it's even set to 9,600 baud, so it clearly is working. So the real question is, why is it not being picked up by processing.org? Or maybe it is. Okay, it's getting 255 for some reason. Okay, maybe it's on the wrong port. Maybe if I take out print line and just run this. Okay, I've got an idea. Maybe it's just going way too fast. Maybe what I need to do, sorry, I'll take out the serial monitor there, is set this to 10 milliseconds. That way, there'll be a bit more of a delay, and you know, it doesn't send a constant stream. It just sends a regular stream. So let's try that right now. Okay, I think I got something here. COM4 39. I'm twisting the thing, and it slowly is changing. Okay, I think that was the problem. It was just way too fast. Okay, I'm going to loom this up to 1/10 of a second. And I'm going to run this. And I'm also going to make sure you see the result. Oh, no, give me a sec. Okay. So there we are. That's the actual result of the Arduino logo. We can see it. Now let's try turning the dial. Aha! There we are. Look at that. So that's 0, so it's pretty much red. And as we go, 15, 23, 64, 89, 1125, you know, and there we all the way to the end. So that's what was happening. Yeah, we set the color in this, just to give you an idea of the actual processing. We set the color to hue, saturation, and I forget what the last one was. But the idea is that this is the hue, that's the saturation, that's brightness, So it's at full brightness, it's at full saturation, and only the hue is going through it. So by turning the dial, we're going through the whole rainbow spectrum, you know, violet, indigo, blue, green, yellow, orange, and red sort of thing. It puts down a background, and then it just prints the logo. And because the logo is transparent, we see the background through it, which allow us to actually, you know, change the color of the background. Now that's all well and good, but the cool part is we're doing it with the Arduino. Now I discovered what our mistake was. My mistake, well actually I was following the book, so it's the book's mistake, is set the delay only to 1 millisecond. This was flooding it with so much serial communication. I'm guessing that processing.org couldn't handle up. So I've changed it to now it only sends 10 signals a second, and the result, you can see for yourself. We're going through the whole spectrum. You just turn this dial, and it's just like that, see? It goes through the whole thing. Oh man, that is really cool. But you see, that just shows it. With that serial monitor we've been using the whole time to see it, that can be used to communicate with anything. We can set up any sort of program to communicate with any sort of input. We can put buttons there and make it jump around. we could do any, right now we're just having a logo flash different colors, which is pretty damn cool. But we can like have buttons and press it and it does something on your computer, or maybe like you've got a great big emergency button and when you hit it, a tweet gets sent out saying this button's been pressed. Or you could set buttons, or we can even mix and match sensors. Like a light sensor, and then if the light sensor get overshadowed, maybe it says, hey, it's brightness, or I don't know, weather station, for instance. That's a good example. Look, you can do tons of stuff, and this is only the start. And if I wanted to, I could try to just code an extra thing, but I think we've gone enough. This is hacking the logo. I think we've only got one. It's pretty exciting to actually see the computer control directly through the Arduino. And yeah, I think we've only got one last exercise left on this book before this entire thing is completed. The last one is hacking buttons, and we'll get to that in the next one. So if you've been with me this far, thank you very much. It's been a fun thing, hopefully, and I'll see you next vid. Okay, I said I'd be stopping with this exercise, but I just discovered something. So this is an example that comes with the processing library. You get it by going to File, Examples, Basics, Camera, and Perspective. So as you can see, it's basically a simple 3D thing. But what if we can I want to try something else. So I want to see if I can rotate this just by using the potentiometer. So let's go back to the codes that we had. It was obviously field of view. Okay, so the camera gets changed depending on how high up the thing is. So left and right makes you zoom in and out, and up and down makes it. So what happens if we okay, so this is probably the smallest field of view, that's probably the meanest. So this is about 0.5, I guess. So we'll just replace this so that we no longer have field of view. See, what that previously was doing is, there we are. So what that previously was doing was seeing how left and right you were. If at the very left you were fully out, if there was this in, and then using that to determine field of view. But now it's just, great, we've got this portably. But we know what we're trying to do here. We want to actually get it, the mouse is going up and down moving this, but we want to get it so that the potentiometer changes that. So that's the camera Y, and it's divided, yeah, camera Y equals height divided by 2.0. So the height is determined by the height of the actual thing, I assume. And we divide that, so that must be a little bit up. Okay, I'm just trying to figure this out. Screw it, let's just type in BG color, which is the exact same. Basically, I merged the two examples together behind the scenes, so this is kind of like this is more of an example of what you can do rather than, this is how you should do it. If the height is camera Y. Yeah, screw it. Let's see if this works. Okay, no, it doesn't work. Alright, let's try that again. Question is, where is mouse Y? That's the real question. Somewhere around here there is mouse Y. There's mouse X. Where's mouse Y? Ah, there we are. Yeah, there we are. So I was getting confused. So we get the mouse Y, and we say we divide it by the height. But that's not us. We are taking a BG color, which is the same, which no longer controls the background color, and dividing it by 255, which we know is the highest value. So now let's try to run that. Okay, so there it is. The only question is, with everything else the same, can this potentiometer actually rotate the 3D object? Let's see. Ha! There you go. We have got tactile controls for controlling a 3D object. That is pretty neat. Okay, just an example. This is just an example of what you can do. Obviously, I was just substituting the mouse controls for the value that we pulled up. But there you go. That's the sort of stuff you can do. Oh, you could try to engineer your entire 3D workstation with controls like this. Well, I'll probably be too. Anyway, I think that's enough of this activity. Let's move on. and thank you for watching.